In this video, I'll try to solve both of these problems. We'll see how much time I have. Which of the following statements are true? I'm going to look at these, and the rule is on these that I've got a quantifier. I've got either a negation or not out front. I've got a quantifier, which is either a for all or there exists. And then I've got some sort of predicate. And then I've either got a negation or not on a predicate. Okay? And the rule is, and we can figure this out by logic, that you switch all three of them. And you've got an equivalent statement. Okay? And so here, in part A, if I switch the thing out front and add the negation, turn the for all into a there exists, and negate the thing on the inside, hey, I did all three, so these two are equivalent. So this is true. The next one, let's see. I had a not, and I had a for all, and I had a not. Here I don't have a not, I have an exists, and I don't have a not. So I switched all three again. It's true. Here I had no negation, I had an exists, and I had a negation here. It looks like I switched all three of them again. I have a negation out front, I have a for all, and then I don't have a negation. I switched all three again, so it's true. Next one. I had a negation out front and it exists, and then no negation on the inside, and I've just reversed that. Now I don't have a negation on the outside. I have a for all, and I have a not on the inside, and so I've switched all three of them. And so all three are true. And in fact, these are just four ways of writing essentially the same rule. And let's see here. If I were to interpret these in terms of the last problem, for example, if P of X were, if A were the set of all people and P of X is a statement that the person is wearing a green shirt, let's say, then the first one on the left of part A says everybody's wearing a green shirt. On the right it says it's not the case that there's anybody who's not wearing a green shirt. And if it's not the case that there is anybody who's not, then they all are. For part B, it says it's not the case that everybody doesn't do it. That's the same thing as saying there is somebody who is wearing a green shirt. For part C, and parts D, we can similarly reason our way through. Here for part C, it says somebody is not wearing a green shirt. And then for part C, it says it's not the case that everybody is. Saying somebody isn't is the same as saying it's not the case that everybody is. Finally, for part D, it says it's not the case that somebody is wearing a green shirt, which means it's not the case that somebody's wearing a green shirt. It means all of them aren't wearing a green shirt. Okay, so you can talk yourself through those, and please make sure you know how to do that. It turns out, okay, let's read the directions on this one. Negate the following statements by putting a negation sign out front, then rewrite the negation by applying the negation rule for quantified predicates, if appropriate, applied to Morgan's law to the resulting statement. Okay, let's do this. Let's negate it, and I'm going to negate it right here for simplicity, to keep the amount of writing down. If I'm going to negate it here, then that's equivalent to for all x in A. And then I have a double negation, P of x, which goes away, and Q of x. So I followed that rule. Okay. Here it says, okay, so that's it, and I can't simplify that anymore. If I put the negation on part B, then that's equivalent to. Now I'm going to take off the negation on the outside. I'm going to turn there exists into a for all. And then I negate the thing on the inside, not P of x and Q of x. And I can rewrite that as for all x in A, either not P of x or not Q of x. And here I applied De Morgan's law. I negated the outside, I negated both things on the inside, and I changed the and into an or. Okay? For part C, I'll put the negation here, and then write the equivalent statement. I write there exists an x in A. And now when I negate the thing on the inside, I get a double negation, it just goes away, such that P of x or Q of x. Okay, nothing I can do to simplify that one. Finally, for part D, if I negate it out here, then it's equivalent to there exists an x in A such that not P of x or Q of x. And I can simplify that by saying there exists an x in A such that not P of x and not Q of x. And I'll try to make my and a little bit nicer there. Okay, so this one, I hope you see what I've done here. The last 2 or 3 problems have all been about the same rule right here. And you should not only know the rule by saying we're going to flip all 3 things, change all 3 things around, but you should also know the rule by being able to talk yourself through these examples and seeing that it really does make sense. Hope that helps.